Hello and welcome to this little presentation. I want to show you another example of a TEF editor, and this time it's an editor for the object constraint language OCL. Because OCL is always used to describe queries over a model, I prepared a little model for you, and we see here a PetriNet meta model, and we have classes and properties and operations here, and there is one query operation, and this is implemented with an OCL expression, and I will simply use that as an example. So I open our OCL editor on this operation, and we see the OCL expression that implements this operation. So this looks like a normal Eclipse editor, and it is a normal Eclipse editor. It works just like the Java editor in Eclipse based on this background parsing strategy. So always when I change my text, after a few seconds, a few moments, a background process starts to process my text, generate a model from it, and with this model all kinds of checks and stuff are done. And so we will get right into it, and I show you how this model thing works. So let me open the normal EMF model editor, where we can see all the models handled in the background. So here we have a view on the current editing domain, which contains here the OCL meta model that the whole editor is built on. We used the existing OCL meta model from the UML+OCL projects. We here have the meta model eCore. Here we have the EMF representation of this meta model, of this PetriNet meta model. And of course here we have the model for the OCL expression that we just saw. So I open it a little bit, and let us compare this model to the expression. So we have on the top, as a top node, we have an iterator expression. On the left hand side of the iterator we have a property call, and on the right hand side we have an operation call, and these are just the items that we can see. So this here is the iterator call with an property call on its left hand side and an operation call, operator call here on its right hand side. Just to demonstrate you, let me change this expression to something else, and when we go back to the model we see that the model has also changed. So now we have this let expression on top, and this iterator expression is just the body of the let expression. I change this back now. So what happened here is that in order to create this OCL editor, you created some templates that describe the concrete textual notation of OCL based on the OCL meta model, and from this template TEF generated a parser, and this parser is now used to create a model representation from this text. So when I introduce deliberately an error here, we get an error message that the parser could not parse the document because of this error. And now of course we have here still the old model because the parser couldn't create a new model. So I changed this back. So this is the parser part of the reconciliation of our model here. The problem with the parser is that it is based on a context-free grammar, and as you know, context-free grammars produce tree-like structures, but meta models produce graph structures. So you have some features in a grammar that you can't describe, you have some features in a meta model that you can't describe with a grammar, and these are references in your model. And if you look at OCL, you have something like this variable declaration IP here, and here you have a variable usage, and in an OCL model these two elements are connected. But this connection cannot be described by the grammar, so you simply, in the text, you have simply the connection by name, use the same name for both things. But after parsing, you still have to resolve these references, you have to create this connection. So this is the next part that comes after parsing, resolving all the references. So when I produce an error here, the resolving could not take place because this name I could not be found in the model, so we get this error here, and I have to change it back to IP so that this name could be resolved to this definition here. In OCL we have lots of names, so also this token input places are just named references to something, to properties defined in the meta model. So we have input places here and token here, and the same thing when I use something that isn't in the meta model, I get an error. Also this for all is just a named reference to an iterator for all defined in the OCL meta model. And tightly connected to name resolution is code completion, which is used to provide all the names that make sense in a certain context. So when I request code completion here, I get token as a possibility to enter at this point here. Yeah, and that is also true for variables and whatever. So now we have done the parsing, and after the parsing we've done the reference resolution, and we have now a model for our OCL string here. But still this model can possibly contain errors, and that are error conditions described by invariants in our OCL meta model. So in OCL, for example, we have such operators which only make sense when they have an integer on the left side and an integer on the right side. So when I, for example, change one of the integers to a string, I get an error because this type constraint was violated. And this works again based on the templates. Based on the templates, you simply define constraints for your meta model, and whenever a constraint gets violated, you get this error message here in the OCL editor. So that are basically the main things that I wanted to show you. The TEF based on templates creates these editors with all these error annotations, code completion features, and you also get some syntax highlighting. There's a last point that I want to show you, and that is about how you can use TEF editors within a graphical editing environment. For this example, let me open a graphical editor here. Here we have an activity editor that we built with a graphical editing framework, and the clue about most graphical notations is that even they are graphical and you have all the symbols in them, you still have big chunks of structured text. So in this example we have a few OCL expressions here in this diagram, and when we want to edit something like that and we only have this field editor here, it can be very tiresome, and therefore we simply integrated TEF editors within GEF, so that when I click here I get the same OCL editor that I just had in the other example, and I have all the features here that I had in the standalone editor. So I have code completion, I have this syntax highlighting, I have all the error markers and whatever. So we just think that this is a very important application for the TEF framework, because graphical notations very often contain structured text that you need a capable editor for. That is for today, and I thank you very much for listening. And if you are interested in TEF, please continue to read our websites, especially the documentation section. Thank you very much.